Hey guys, so I just wanted to kind of clarify what we did today. So if you deleted slides 32, 30, 29, and 28, you should be left with a slide that looks like this. All right, and so what I'm going to have you do is actually modify this one slide to make it look like this. All right, so in order to do that, you could just click this, copy, paste, and shrink them down to make them this size. Each one should have a title. Methane lake liquid is the first one. Methane lake freezing is the second one. Methane lake evaporating should be the third one. All right, and so what you're going to do is modify this a little more. Okay, and the first thing you're going to do is you're going to shrink that down, the middle one down. Next thing, spread them out a little bit. Next thing I'd like for you to do is list the properties of a liquid. There's going to be 3 of them that you're actually going to get from by looking into the modeling tool. There will be a word bank in this modeling tool, and pull the 3 ideas out that fit the liquids here. Copy this, copy the properties of liquids 1, 2, and 3 so you don't have to retype it. Do it and change it to solids just like that. Copy that one, paste it over in evaporating, put properties of gases there. Okay, and again, these properties for the solids and gases should be found in the modeling tool. If you click on it, and you'll get into Amplify. Next up, draw an arrow from the liquid to the evaporating to gases. Then do the same from a liquid to freezing. Add text boxes. Put a border of black around it so you can see it. Okay, resize things so they fit. Then you're going to, I put some questions in here. So what's happening to the thermal energy and kinetic energy in this case when it moves from a liquid to a gas? What is this process known as? Is it evaporation, condensation, melting, or freezing? Same from a liquid to a solid. What is that process known as? What's going on with the thermal energy and the kinetic energy? Both of them, not just one of them, but both of them because they're related. All right, and then we're going to do it from a macro scale first. So in this case, you're going to go ahead and draw Titan's Lake. Okay, so we're trying to answer that question, what's happened to Titan's Lake? Did it freeze or did it evaporate? So I colored it blue because that seems to fit with being a liquid. All right, then I copied it so I could be fast. So I just grabbed this from Shapes to make the original one. Okay, and then I colored it a different color. I added some white lines to make it look like more like ice. Okay, or frozen. And I copied it again. And I moved the lake over to gases, because this is the example, the macro view of it turning into a gas. Okay, so I'm going to show some evaporation lines. I grabbed that cloud from the Shapes called callouts. You can grab it from there. So you can form a cloud. You show some more evaporation lines. Okay, show the direction in which the evaporation occurs. So put some arrows in. Okay, and then you start filling in the information. So that's pretty much it as a macro scale. All right, then on a micro scale, what you would want to do is you would add to it a little arrow. Okay, an arrow. And then, so we want to add a magnifying glass. So in a magnifying glass to me is a circle. So I'm going to add a circle. And then show me what that looks like on a molecular level. Now we know with liquids, they move around each other pretty freely. So you want to add the molecules, circular molecules, and add little squiggly arrows showing them moving around each other. Do the same thing for the solid. So you'd add a little arrow and magnifying glass here, zoom in on it is what we say, and then you would show the molecules of a solid, and you'd show just one little squiggly line underneath each to show that they vibrate. and do the same thing for gas. So you'd point an arrow to the cloud, zoom in on it by drawing an arrow in the circle, and you'd show them spread out, and straight arrows showing that they move in a straight direction until they collide into something. So hopefully that helps make yours look like this, and that's what I'm looking for, okay? Hopefully that helps you get today's lesson done. Now, I know I said something about chapter 2. If you've gone ahead and done that, fantastic, you're ahead of the game. If you haven't done it, don't worry about it yet. We're going to work on that tomorrow. All right, guys, hope you guys are all doing well. Hope to see you soon. Take care.